Very quickly, the chapter model. Chapter 3 has a model, and I'll just state up front. As I said a minute ago, there are many different ways, many different routes to get to the same answer in Excel. What I've tried to do in the slides that you've got, and the revised slides that you will have, is choose the simplest, easiest way of getting to the end. A lot of the models that Lou Gopensky has produced has got not only my way, but many other ways as well. He believes that that helps students understand that there are multiple ways of getting to the end destination. I believe that sometimes students find it confusing because they don't know which route to take. So if you're wondering what's easiest and simplest, the ones I use in the slides, I think, are the easiest and simplest way to go. Having said that, a model has different ways of doing things, and it's always good to know different ways of doing things. So it goes through all the examples we talked right now. Again, here's an example of where where he does things differently. I just used the FD function, as you saw a minute ago. He calculates the value at the end of each year, and then he adds them all up. So I've got one calculation, he's got 7. Same answer, you get the same answer, but it's just this, I think the FD function is simpler. The other things that are on the models, everything else we've talked about. The power of compounding, compound interest. In a few weeks, Jeffrey Sims has asked me to give a session on personal finance, and this is the kind of graph I'm going to show that everybody in this room, you should be saving now, because look where you will be if you start now versus if you start when you're 70. Which, unfortunately, a lot of Americans, that's when they start to save, is when they get very far into middle age or old age, and that's not enough time. Right now, you have time on your side, and that graph shows you the power of compound interest. There are all the other models that we talked about in here as well. The present value of a lump sum, again, the formula, again, Lou tends to take them by year and add them all up later. I tend to use just the formula. You can solve for the interest rates using the rate formula. And solve for time. In other words, how often do you need, how long will it take you to pay off a loan given the interest rate is this? The ordinary annuities and annuities too as well. So you can wade through the model at your leisure. Everything I've talked about is in there, as well as a lot of other things. So let me give you one quick in-class problem. You can try this out. And this involves a formula with an Excel formula that we haven't talked about today. When you have, this class is my daughter's class. This is what my orthodontist told us when she needed braces. He gave us the choice of two payment options. $4,000 right now, or make 36 monthly payments of $121.69. So, what I want to know is what nominal annual interest rate is built into that plan. And I'll give you a hint right now, you have to use the rate formula, R-A-T-E. So if you just put equals, rate, parentheses, it'll then prompt you for other inputs. So let's see if you can figure it out. And remember, it is asking you for the annual interest rate. Okay, does anyone have an answer? Please.
0.5%?
Okay, that's the right answer. You're on the path to the right answer, but I asked for the annual interest rate.
0.5013?
So what did you calculate?
I calculated that's the amount that's going to get compounded monthly. So it's
Right.
monthly.
So what do you have to do to that 0.5?
Yeah, turn into the effective annual rate.
And what would you do to do that? It's not the effective annual rate. You've got a periodic rate and you've got a stated rate. What have you calculated?
I calculated the periodic.
You've got the periodic rate. So what do you have to do to the periodic rate to get the annual stated rate?
Oh, times 12.
Which gives you,
6%.
that is the correct answer. So what did she do? We used the rate function.
Oh, I missed the negative. I missed the negative. I was like, oh.
There are 36 months. Payment that the orthodontist offers is $121.69. PV is $4,000 because essentially that's the opportunity cost. I can either do one or the other. I'm foregoing the $4,000 in order to have the other cash flow stream. The 1 month rate of return is by using the rate function. It's simply the 36 months with $121.69 in cell A14 and the B14 and then the PV in 4,000. That gives you 0.5%. We then have to multiply that 0.5% times 12 to get a 6% annual rate, because the 0.5% is the periodic rate. So what can I do with that 6%? Why have I asked you to calculate that? What did I do with this when the orthodontist gave me that number? How is it useful?
See what your future value of your cash flows will be compared.
Okay, let's step back a second. What is the 6%? What did I get?
Stated
Cost of,
It's the cost of,
not borrowing the money, but paying the money back, paying the overtime.
right, so it's the cost of borrowing, essentially. I'm going to pay the orthodontist a rate of interest of 6% in order to have credit. So what can I compare that 6% to?
$4,000. What you could earn on that money if you invested it.
Or if it's a loan, what I would be paying to the bank. If the bank was going to charge me 4% for a $4,000 loan, what should I do? Or would you rather pay 4% or 6% interest? You would go to the bank. So what Jill's getting at is, suppose I had lots of money hanging around and I was getting 8% on my investments, then I'd probably want to leave the money in the 8%, getting the 8%. So this is a useful example. This is an example of how time value analysis can be very helpful even in daily decision making, because all of you will face these kinds of interest rate choices. Okay, any other questions about time value analysis, the concepts or the principles?
Yeah. Why would we talk in terms of stated rate? Like why, when you're comparing the amount that you're getting charged at the dentist versus at a bank, why wouldn't you use an effective annual rate instead? I mean, do you just assume that both compound monthly?
You can do it, and you can do it multiple ways. You can compare the annual rate of interest from the bank with the effective annual rate of interest on this loan. The question asks, what was the stated nominal rate? You can still calculate effective annual rate if you like. Any other questions or about the concepts or principles of time value analysis? Gone longer than I normally do.
You just mentioned again, because I forgot the times 12, so you said when you figured out the rate, you just got the periodic rate. Is that for each month, or that's for each, well, yeah, what is that for?
So, here's the example we went through. Periodic rate, the stated rate is 10%. 10% compounded semi-annually. So the periodic rate is the stated rate divided by the number of compounding periods per year. That's 10% divided by 2 gives 5%. So 5% is the periodic rate. And that is simply, the formula for it is simply the stated rate or the annual rate divided by the number of compounding periods per year. Is that what you were asking?
Yeah. So I'm wondering, when we did the rate, did we get monthly? Is that what we got? Okay, that's what
Yes.
I was.
In the interclass, yes, you had a monthly rate,
Gotcha.
compounded monthly. So 12% per year compounded monthly, the periodic rate would be 12% compounded monthly would be, what would the periodic rate be? 1%. That means instead of getting 12% on one day per year, you get 1% every month. Other comments or questions? Okay, let's take a 5-minute break. We'll come back with the rest.